This is OPUS, a multidisciplinary consultant which took a journey to expand a transit line. It is a broad account of OPUS engineering expertise, construction capability, and extensive system works know-how in the implementation of a larger network for an effective urban transport system. OPUS is the project consultant appointed by Prasarana to manage the implementation of the Kelanejaya and Ampang Lines LRT extension project. At peak, there were in total 220 numbers of OPUS personnel involved in this project, of which most of them were engineers or professionals from various engineering disciplines. Generally, there were civil and structural design engineers, architects, contract managers, and railway systems engineers, including rolling stock engineers involved in the project. The project consists of two LRT line extensions, Kelanejaya Line and Ampang Line. The Kelanejaya Line comprises of 17.7 kilometer length of alignment with 12 stations, whilst the Ampang Line comprises of 18.1 kilometer length of alignment with 11 stations. In addition, 50 numbers of new light rail vehicles or rolling stocks were procured for the Ampang Line extension project, and as a result, a new depot had to be built to maintain and stable the new light rail vehicles. Generally, all the stations are provided with lifts and escalators, toilets, praying areas, and facilities for the disabled, such as ramp facilities and low-ticket counters. As for the new depot, it was constructed on 35 acres of land. The depot is an integrated composite deck elevated approximately 8.5 meters above ground level and consists of a main office, maintenance building, and stabling yard. It serves as a facility for stabling, cleaning, inspection, light and heavy maintenance of the LRVs for the Ampang Line. The project faced many challenges during its various phases of implementation, whether during the land acquisition phase, design phase, tender phase, and construction phase. In total, there were approximately 100 hectares of land acquired for the project, 30 hectares for the Kelanejaya Line and 70 hectares for the Ampang Line. 65% of the land area is within the government's reserve land and another 25% were owned by private owners. In order to manage the public, especially the affected residents, continuous engagement sessions were held with them at the early stage of the project implementation. Most of the engagement sessions with the affected residents were held jointly with the relevant authorities. All their concerns were noted, and whenever possible, mitigation measures were implemented to minimize the impact. Their main concern mostly were on the noise and visual impact, especially when the alignment was passing through nearby to their houses or condominiums. One example is at the Saujana residency area along the Kelanejaya Line, of which the alignment passes through between two high-rise condominiums. We had to install a guideway envelope to function as a visual and noise barrier to minimize impact to the affected residents. The most critical activity during the early steps of project implementation was on obtaining the approval of the railway scheme by the relevant authority, SPAD, or Land Public Transport Commission. Once the railway scheme was approved by the authority, only then the proposed alignment is deemed approved or frozen, and so the subsequent detailed design can proceed aggressively. Prior to approving the railway scheme, it had to go through public scrutiny. The railway scheme had to be on public display for review. We had to compile the public feedback and, whenever possible, to take them into consideration during the detailed design. There were approximately 30,000 numbers of drawings produced for this project, and our main challenge was to ensure full integration of designs between the various engineering disciplines, such as geotechnical, drainage, electrical guideway structure, station structure, and mechanical and electrical building services. The most difficult task was to ensure complete integration of designs between the civil and structural works and system works, such as track works, signaling works, communication, and power supply. These tasks had to be performed diligently by our team in order to ensure that facilities which were to be constructed meet the system works requirements. This is to avoid clashes between the facilities works components and the system works components and minimize abortive works. The scope of works for the project is generally broken down into 3 categories: advance works or utilities relocation, facilities works or civil and structure works, and system works, including the LRV or rolling stocks. In total, there were 38 numbers of works packages for the project. One of the most critical issues to be addressed when carrying out construction works within the city centre and busy roads is on the management of safety-related matters, as it does not only involve the construction workers but also the public. Besides increasing the number of safety personnel on the project, we also made sure that the workers were provided with adequate safety training before they were allowed to carry out any type of work, as we believe that safety is everyone's concern, not only to the safety personnel, but also the public. A lot of safety workshops and conferences were organized internally among the stakeholders in order to create awareness on the importance of safety at the site. In some cases, we had to revise the Standard Operating Procedure (SOP) or revise method of construction to minimize the risks of potential incidents. The main challenges at the initial stage of the construction were the relocation of the existing utilities. There were water supply pipes, sewage pipes, underground low-voltage cables and high-voltage transmission lines, telecommunication cables, and gas pipelines that were required to be relocated first before piling works could commence. Since most of the existing utilities were buried deep underground, it was very difficult for us to detect them in advance so that they could be relocated ahead of the piling works. Most of them, unfortunately, were identified too late, which were discovered only upon the commencement of piling works. As a result, the piling works had to be temporarily stopped and recommenced only after the existing utilities were relocated. The delays in the relocation of the existing utilities had consequential impact to the subsequent construction activities, especially the construction of the facilities work, and also later caused a knock-on effect to the system works installation program. This phenomena, the late relocation of the existing utilities, had caused substantial delays to the overall project implementation and became a serious concern to the stakeholders, especially the client and the government. We had no choice but to bring back the work program on track, which means that we had to accelerate the remaining construction activities. Together with the client and contractors, we implemented various mitigation measures to accelerate the works. One of the most important actions we undertook were to work 24/7, day and night and weekends, and also to mobilize additional resources, labor and machineries so that work can progress concurrently at various multi-fronts. In some cases, we even changed the original designs with the one that shortened the construction period in order to accelerate the works. A full spectrum of communication systems which links to the Operation Control Center allows constant control and monitoring to ensure passengers' safety. The power supply is designed to provide a stable and uninterruptible system. It consists of high voltage supply from TNB intake, traction power supply for the trains, and low voltage supply to all stations. The scope of work under this contract includes the design, manufacture, supply, delivery, testing and commissioning, and handing over of 15 units of train sets. Additional provisions under the contract include a supply of onboard communication base equipment, spare parts, special tools and equipment, training, and the contractor is also obliged to buy back existing LRVs and also to modify the existing equipment to suit the new LRVs. Our efforts were meticulous and calculated. With all concerted efforts from all parties, the project was successfully completed on time and not only met the client's objective, but also the government's aspiration to improve the Klang Valley public transportation system. We took it on with one single notion in mind: pushing boundaries and innovating to advanced community. OPUS, a member of UEM Agenda, uniting lives for a better future.